Okay, question number 2 looks at this parabola and we're attaching a tangent at x equals 1 and they're stating the axial intercepts. Okay, so I've got 4 minus x squared. It's actually been drawn for me and the tangent's been drawn and the tangent touches at x equals 1. Okay, so interactive calculation line, tan line at x equals 1. And that gives me t1 equals minus 2x plus 5. And of course, that's got a y-intercept of 5. I'll accept y equals 5, all the coordinates. And if I set it equal to 0, I don't have to type equals 0. Advance, solve for x, I get 5 on 2. And of course, that's my y-intercept, x-intercept, and that's my y-intercept at A and B. Okay, so that's part A done and B done. Part C starts to look at the area that's shaded, the area that's here. Now keep in mind that if I was to use calculus for all of it, I would have to do 2 definite integrals. One definite integral from 0 to 2 of t1 minus, what's it called, h of x, and then plus the second integral from 2 to 2.5 of t1 dx. So this would be the area under the curve, but this bit is 2 areas trapped between curves. Or you could think about it as being this large triangle OAB, minus this white bit. And that's what I've suggested you do. So OAB will be a half times 5 on 2 times 5, minus the integral from 0 to 2 of f of x. So let's do that. 0.5 times 5 on 2 times 5 gives me 25 on 4. And then the integral from 0 to 2 of 4 minus x squared the x gives you 16 on 3, and 25 on 4 minus 16 on 3 is equal to 11/12. Okay, so that's getting an idea of what to do when we're attaching the tangent at 1. But what did we do when we attach the tangent at any point P, where P goes from 0 to 2? So I can't include 0. And I can't include 0 because the tangent at 0 would be a horizontal line and I'd have no enclosed area. Okay, so if I consider bigger than 2, but bigger than 0 and up to 2. So if I go to the top and grab this, but I now do it at P, that's going to give me y equals minus 2px, y equals minus 2px plus 4 plus p squared. And if I was to find the x-intercept, I'll make it equal to 0 and go solve for x. So that's that expression. And if I can combine those two together, that gives me that. Or you could write that, either of them is acceptable. And of course, if x is 0, then the y-intercept is 4 plus p squared. Okay, now to find an expression for the area that's trapped will be a half, 0.5 by bracket around all of that and get rid of that bit and then put a bracket in and grab this and put that there and press XE. That expression, which is that, minus the same integral as before, which is 16 on 3, because 16 on 3 doesn't change because that's this white bit here. And if I want to find the minimum, I'm going to take this expression and I'm minusing 16 on 3. And I would like to do interactive calculation, F min But my F min will be about P, not about X. And my lowest value won't be 0, so I'm going to put 0.1. And my largest value is 2. And there is my minimum value, 32 root 3 on 9 minus 16 on 3. And that's at a p-value of 2 root 3 on 3. So I've had to alter and make up a value bigger than 0 because I can't have 0 because 0 wasn't a value for p. Okay, so that's question 2.